All right, I want to welcome everybody to our next session today. This one is going to be one focusing on workflows for active learning. If you haven't seen me already, I'll go ahead and introduce myself again. My name is Trey Pierce, and I'm a solution engineer here. I'll be moderating for you today. Before we get started, just a few quick housekeeping mentions. You might have heard this already, but all attendees will be muted throughout this session, and we encourage you to ask questions, which you can do by typing into the Q&A widget in the top right-hand corner. We will do our best to, I think we should have a few minutes for questions at the end of the session, but we'll try our best to get our hands on all of them. Last note is that today's session will be recorded and will be made available after the event. I've already done it once today, but I suppose I'll get to do it again. I am very happy to be introducing Alfredo Ramos, our Senior Vice President of Platform here at Clarifai. Quick note about him, and looks like this is a slightly different description than the last time. So for over 20 years, Alfredo has worked in various technology companies with a focus on product-led enterprise growth. At Clarifai, he's responsible for product marketing, research, and engineering. Prior to Clarifai, he was the general manager of Vistaprint's digital business. During his career, Alfredo has worked in various leadership roles at Webs, Web.com, and Network Solutions. He holds his MBA from the University of Pennsylvania Wharton School, MLA in Information Systems from Harvard, and an honorary BS, honorary Bachelor's in Science in Computer Science from the University of Toronto. Okay, I'm gonna spare the context background on Clarifai here because I think Alfredo is just going to reiterate and go into that himself. So with all that said, I'm gonna hand it over to you, Alfredo, to lead the session.
Thank you, Trey, and I hope you guys can hear me. I'm very happy to be here talking a little bit more about some of the things that we've been working on at Clarifai. Some of these things, Matt, if you caught Matt Zieler's keynote, were covered, but we're going to go into a little bit more depth. In this case, as I mentioned, I'll be covering active learning workflows, and it's an area that we've been doing some pretty cool stuff in. Before I do that, let me start by giving you a little bit of background on Clarifai. Clarifai is a leading independent provider of artificial intelligence for unstructured image, video, and text data. Our end-to-end computer vision and NLP platform covers the entire AI lifecycle. The company was founded in 2013 by Matt Zieler, our CEO. Shortly after founding, he won the ImageNet competition. In fact, he took the first 5 places in that competition. Got people's attention, certainly. ImageNet is a prestigious competition for computer vision. Since then, we've won numerous awards. We were recently recognized as a leader in the Forrester New Wave for computer vision platforms. We were nominated as a leader in a crowded field with some competitors like Microsoft and Google. So very proud of the work that we did and the journey we've taken to get to this point so far. We are headquartered in New York City, but we also have offices in Washington, D.C., San Francisco, and this year we opened up an office in Estonia in the city of Tallinn. Wonderful. Okay, I'm going to tell you a little bit about the Clarifai platform before we go into some of the hands-on show and tell. Clarifai's platform is an end-to-end deep learning platform for unstructured data. Like in all AI, it starts with the data, and we're able to process image, video, and text data. What we do is we help you transform your unstructured images, video, and text into structured data. And we do so, and we help you do that significantly faster and more accurately than you would be able to do it if you were to do it manually using humans. The platform consists of 6 core products that represent all of the building blocks for the AI lifecycle. The first is Scribe. It's our machine-powered data labeling solution that uses AI to improve the annotation workflow by an order of magnitude. Scribe also includes integrated data labeling services. If you don't want to deal with labeling yourself, you can outsource it to us, and we'll take care of it extremely quickly on top of our platform. The next product is Spacetime. It's an AI-powered search engine for unstructured data, especially when you're dealing with large volumes of data. Being able to index, search through that data to ultimately then be able to slice and dice it in multiple different ways and integrate it across the AI lifecycle is critical. And Light is a product that helps you train various types of ML models. Here, now that you've put your data into the platform, you're able to leverage that data to give, and we help you get best-in-class accuracy using a significant amount of intelligence under the covers around multiple different types of modeling architectures for very high accuracy models. We do a lot of things under the hood, like hyperparameter optimization, and just really making it super simple so that you can train models at the click of a button and not worry too much about all the difficulties that come along with that. Armada is a solution to dynamically scale thousands of your ML models across thousands of servers for inference at full production scale. If you work in AI, you know that one of the least pleasant things that you need to do is deploy your models for production scale. Typically, it involves having to work with external people external to your team, like DevOps and infrastructure. And we try to remove all of the complexity around pushing your models to production so that you don't have to do it. And in this case, we let you not only push the models that you built on the Clarifai platform for production scale, but you're also able to bring your third-party models in and deploy those. Mesh is our workflow tool that allows you to take the ML models and combine them in multiple different ways to power multiple different types of business outcomes. I'll show you a little bit about how that works in this presentation. And today we're very happy to be talking more about Flare. It's a new product that we're working through, and we will be working on in the years to come. This is the ability to take our ML capabilities to the edge. All of these products are part of our AI fabric. We're able to host our platform not only in all of the clouds, right? AWS, Azure, Google Cloud. We are one of the only vendors that is able to do that. But also, we are able to host our platform in bare metal, depending on your operating environment. You may need to be on bare metal hardware. Sometimes it's for cost efficiency, sometimes it's for security reasons. We also have air-gapped options if you need your platform to run fully disconnected from the internet. And of course, we're able to deploy components of the Flare product into IoT devices and mobile. Okay, I wanted to very, very quickly give you a sense of some of the use cases that Clarifai's platform is able to enable. We work with multiple different companies across the world to power solutions around various types of use cases. Moderation is one of the early ones that we became known for. And here we help companies that have a lot of user-generated content and marketplaces kind of scan through their images and their text and their videos and make sure that there's no unsafe or undesired content within them using our models. Visual search is extremely common in the retail environment, also manufacturing, and frankly, it's an important building block of our platform. But specifically to retail, through things like Snap and Search, we're able to help you take a photo of a product, for example, upload it to your app, and be able to find the product that you're referring to. In the manufacturing world, we see that people want to be able to upload, for example, parts, unless manufacturing is quite complicated with thousands and thousands of parts. And so being able to upload a part, detect what it is, and get more information about it is extremely helpful. For companies that have a significant volume of either imagery or products, we help them with automatic tagging. This is common across e-commerce marketplaces. It's common across stock photography, digital asset management companies. And it's very common in media companies that have a lot of video. We help you use our ML workflows to automatically annotate your content. And it's particularly important when frankly, doing so with humans is not realistic. I'm going to just highlight a couple more of these. In the security space, we can use our edge capabilities to detect people, vehicles, and other objects across physical spaces, triggering alerts when certain conditions are met. For example, in predictive maintenance, one of the things that's actually critical for manufacturing is being able to observe your equipment, in this case using computer vision, to detect things like machine corrosion, paint degradation, et cetera. And the final thing that I'll mention is around employee safety, also important in the manufacturing industrial spaces, construction as well as a use case that we'll touch on today, where you want to make sure that you're providing a safe work environment for your customers, and you can use computer vision to detect that people are wearing the right protective equipment, to make sure they're wearing hard hats and masks and the right gloves and reflective equipment, but also make sure that they're not walking in areas that they're not supposed to be in, that maybe the right density of people is below the regulatory thresholds at the state or local level. Okay, so today's talk is around trying to automate the model development process using workflows for active learning. First going to start, by the way, I'm going to kind of like stream into like 101 easy level content that it doesn't necessarily assume that you have too much AI background or computer science background, but sometimes it may get a little bit more advanced. I'll try my best to walk the line. When we talk about active learning, we're talking about a machine learning term that refers to various methods for actively improving the performance of your models, right? One of the things you want to avoid when you have a model is what's called model drift, and you want to make sure that your model is continually getting better as the types of input data that it's receiving evolves. And when we talk about it, we're talking about being able to collect inputs from your production environment, pipe that into a workflow that lets you auto-label any input that you see and any concept that you find. If you think that if you're highly confident it's a particular concept, we let you automatically annotate that using advanced workflows. I'll show you what that looks like. But we also let you, if you're not so confident in the concepts that you're seeing, pipe that into a human workforce that are able to manually annotate that using their knowledge. And of course, once you've taken in all this new data that has now been labeled, you're able to train new model versions and evaluate them for improved accuracy. The name of the game here being continually improving your model and making sure that there's a virtuous cycle of models that get more accurate with time. Okay, the use case we're going to walk through today is one where we're going to try to detect construction workers. Again, as I mentioned earlier, to ensure there's a safe workplace. There's an element of this concept of model specialization where we want to be able to use pre-built people models in this case. That's our building block, a pre-trained people detector model. And we're going to help companies abide by federal state regulations for safety in doing so. All right, there's two primary components to what I'll walk through today. One is I'll show you quite quickly how to build this specialized transfer-trained classifier leveraging a pre-built detector model. Before I do that, I'll cover some very, very basic concepts around classification, what a classification model is and what a detector model is. And I'll give you guys some tips on how you can build a transfer-learned classification model quickly. The second piece will be around actually rigging up the active learning workflow, assembling this advanced workflow using production data to fine-tune your model, and piping in input that your model is seeing for either automatic annotation or manual annotation. Okay, very quickly. When we talk about classification, the term classification model and detection models are going to be used throughout this presentation. A classification model helps you classify objects, faces, people, sentiment that are present with an image. Whereas a detection model does a similar thing, but it helps you detect exactly where in an image or video to find people or an object. On the left, you see that we have an interior room, and we're able to detect that there's a furniture, sofa, etc. We don't tell you where it is. We just tell you that somewhere in the image we're seeing that, or our models are seeing that. Whereas on the right side, we're running a face detector, and it tells you exactly the location of a face or all of the different faces that are found within, in this case, images and videos. Clarifai has a number of pre-trained models that are ready to use out of the box, spanning multiple different use cases. And I mentioned this because in this case, we're going to be using our people detector model to kind of accelerate our transfer learning workflow and a transfer training model. I mentioned that I may touch on a couple of topics that may be on the more complicated side for some, less for others, certainly. In this case, I wanted to just briefly have an interlude around transfer training. We at Clarifai talk about transfer training quite a bit. We have some tools around that. We call it a context trainer because what you're doing is you're transferring the learning from one kind of pre-trained, deep-trained neural network and using that to expand upon it. Oftentimes in data science speak, what you'll hear is you take the knowledge that a neural network has learned from one task and you apply it to a new task. These lighter transfer trained models inherit the characteristics of this deeper pre-trained neural network. So the question is, why do you do this? Sometimes you want to take a general model and you want to be able to fine tune it, right? So for example, rather than just detecting people, you may want to detect construction workers. But also transfer learning usually needs 10 times less input, sometimes even less than a fully deep trained model. People often ask how many inputs you need for a transfer trained model. We'd like to say that for each concept, certainly somewhere between 50 to 100 inputs, whereas for a production scale deep trained model, you'd be looking at easily 1,000, if not more, per concept. Transfer trained models take or can train something like 100 times more quickly, sometimes even more. So super quick way of getting a model up and running. And by the way, they are able to get pretty high accuracy. Okay, into the demo. So what I'll do here is I'm going to start by walking you through our tool. In this case, we have a tool called Portal, and what you're looking at here is a part of our application called Explorer. Here you're able to, as the name suggests, browse through all of the different images within your app. And as you can tell, we've already uploaded a bunch of images containing construction workers. What we want to be able to do is build a workflow that is going to detect the people within each one of these images and crop them out, quite simply. Rather than having one image that has multiple people in it, we want to be able to have multiple images of each crop. And so I'll show you a little bit about how we do that. But before I start, I wanted to just give you a feel for how a classifier works. Again, remember that I talked about the classification model and the detection model. Out of the box, you're able to run our general classification model on top of any image. And in this case, you see that the model is already performing quite well, right? It takes this image and it sees that there is a person, a man, an adult. Taking a couple of different images, we're able to detect men, women within images, groups of people, adults, etc. And so here we're able to detect that quite well. But what I want to be able to do is have a workflow that has two models that essentially takes every single person and crops them into an image. And so here we're able to detect every person using this people detector. Here we're able to detect this woman that's in her construction area, two people walking on the street. Again, every person is detected individually. This person sitting down. And in this case, two construction workers on site are just detected as people. So in order to build that workflow, what we did is we used a tool. This is the mesh workflow capabilities that we have within the platform, where quite simply, you're able to string together a people detector and a cropper. And I'm preparing this to now build a custom classification, right? So we're going to build a custom classifier that's going to be able to take people that have been cropped and is going to classify them, in this case, into construction workers and not construction workers. Now, building a context-based classifier in our platform is quite easy. Here, there's actually multiple different models on our platform in what's called model mode that you're able to use and string together into a workflow. I'm not going to show you all of these different models, but I will show you the context-based classifier that takes in the embeddings from a pre-trained model and or a previous model in the workflow, and outputs out concepts that are detected within that input. And quite easy to do. In this case, you give it a name, And we had already created the construction worker concept as well as the not construction worker concept. So we add these to the model and click on create. Now we've taken all the crops that we had from before, we've added them to an application. I've kind of done this for the sake of time, but these are all the crops that were detected in the individual images. You may recognize some of them right now. They're kind of zoomed in so you can't see the faces. But there's a number of them here. And what we're going to do is we're going to use Explorer now to bulk label all of these things. Again, we select a number of images that we know are of non-construction workers, and we mark them as such. And next, we're going to take, again, a number of images that we know to be construction workers. And similarly, we're going to click on bulk label and mark them as such. So very quickly, we've been able to annotate dozens of construction worker and non-construction worker images. And we are now able to, at the click of this button, train the construction worker model. I would tell you that training this model would probably take 5 to 10 seconds. And what I want to show you is what it looks like. To be able to test out this model qualitatively, what I'm going to do is I'm going to upload a few images that the model has never seen and just test it out. So we'll go back into Explorer. We'll load up the images and we'll see qualitatively how this model is performing on these new images that it's never seen before. Here you see that it's accurately predicting on the right side that this construction worker is in fact a construction worker with 100% accuracy. It's actually 99.9% accuracy. In this case also, it's able to predict that there's a construction worker in this image using the underlying model that we trained previously. And similarly, it's able to detect that this person's not a construction worker with over 70% accuracy and another person that is not a construction worker. Okay. Now, let's do a quick recap. What did we do so far? We trained a transfer-trained classifier by using a pre-built or pre-trained people detector, cropping out each person that was detected into an image region, and using those images to create a classifier by bulk labeling construction workers and non-construction workers, and quickly training a context-trained model to power what will then be a more advanced workflow. So this is where you step into the active learning workflow. And if you recall, active learning is this virtuous cycle where now what we're doing, and if you can put yourself in that mindset, we've built this custom classifier and we want to make it better. And so you can take this kind of starting at the production data, your deployed model, you're able to pipe that in back into, in this case, our platform, but your application, send it through either automated labeling workflows or manual labeling workflows. And once you have a new batch of trained data or labeled data, you're able to train it, evaluate it until you're able to prove to yourself that you are improving the accuracy of the model. So the way we're going to do that in our platform is super cool. I'm going to show you kind of a visual of all the different models you need to put together. All of these are basically models in a workflow or steps in a workflow, right? So a workflow is a graph of different steps or models. The first step is to collect the data from production. Like I mentioned, we'll use a collector to be able to do that. Detecting people within the collected images, cropping them out. In this case, what we're saying is because we're trying to build an automated labeling pipeline, we want to make sure that we're automatically labeling high confidence data. So we're only going to be looking at data that is, we believe is 90% accurate, taking those people, cropping them, send them through our neural network and the custom classifier that we built. Ultimately, that tells you whether it's able to see a construction worker or not within the images and the crops that it's taking in. And we are going to take any construction worker, any crop that has a 70% accuracy or confidence of having a construction worker in it, and we're going to pipe that into kind of an auto annotation workflow. I'll show you how that works. Now, so for context, again, remember that we've built this custom classifier and it's able to tell you whether we have a construction worker. Wonderful. First step is to build a collector within our platform. A collector is the name that we give for this basically tool that can be piped on to your production workflows. And what it does is it samples all the data that it's predicting on, and it feeds it back into your application, collects it back into your application, basically. Super easy to do that within the platform, and we can activate that. The next piece, now that you're collecting all this data, is to make it run through what's going to become this intricate workflow that I showed you earlier. We're going to call this workflow auto-assign labeler task. And by the time we're done with it, there's going to be a handful to a couple handfuls of models stringed together to be able to achieve very complex capabilities. First, we start with the people detector. Again, here we are browsing through the different pre-built models that Clarifai offers out of the box. The people detector is added to this workflow. And then we want to be able to, like I showed you briefly earlier, take that people detector and threshold it, right? So we only want to detect persons that have a higher than 90% confidence of actually being a person. And so we're building this, what we call a thresholder to do that. And when it passes that, we crop it up to the next step, past the image or the image region using our region cropper model. And then we pass it through, again, the neural network, in this case, our general embeddings that are quite good at detecting concepts like people, and the custom classifier that we had built earlier. So now actually, first I have to add this custom classifier that we built. And now you see kind of a multi-node workflow that has been put together to be able to, what will end up being kind of auto-annotating any people or any people that the model believes are high confidence construction workers. The auto-annotation piece I'll dive into in a following slide. Okay. First to mention, when we talk about annotation, basically what you're doing is as you're receiving inputs and you're receiving annotated inputs, you're going to be adding the annotations to those inputs, right? So if you have a region of an image that has a person in it or a construction worker in it, you're going to be annotating and adding kind of a construction worker label to that input. And I'm going to try to go a little bit faster because I'm kind of going to be running out of time here. So we've put together this this workflow, and we've added this workflow into an app such that every input that gets processed goes through this this workflow, right? So we've added a bunch of inputs here, and what you're not able to see is kind of the magic that happened in the background by processing this workflow. But all of these images that have been added have gone through the workflow that I added earlier. And so in the background, we've automatically annotated them. And I wanted to briefly show you how we're able to pipe those in to labeling workflows using the Scribe labeler that we released this year. Scribe labeler is able to ingest kind of these automated inputs. And the wonderful thing you'll see is every single input that comes into the labeler already has a construction worker annotation. In fact, without doing any work, you can browse through all of these detections that have been automatically detected using this advanced workflow that we built. In fact, we missed one person here, but that's not a problem because we're able to manually add bounding box labels through the process. Very quickly going to be going through the next couple of steps. Basically what you'll see is how all of these different images were automatically annotated with bounding boxes without us having to do anything. And we go through, I think here, a few dozen inputs with some very accurate bounding boxes for construction workers. So extremely useful. I want to leave you with 2 points before I close this. The first is that machine learning needs to be at the core of any modern data labeling pipeline. There are a few companies out there that are able to put together the ML capabilities across the different stages of the AI lifecycle like we do by building not only AI-assisted labeling tools that focus on efficiency and scale, but also that you are able to use advanced workflows to auto-label your data as you ingest it. Ultimately, in doing so, you're able to create models 10 times faster than you would without actually having AI to assist you along the way. You're able to use AI to label your data automatically. In doing this within a platform, you're able to minimize the data wrangling that goes on, having to move your data across multiple different platforms. And ultimately, this helps you scale your labeling projects. But beyond that, it also helps you create an AI center of excellence within your company. The bottom line is that if there's anything that you should take away from this presentation, is that a seamlessly integrated deep learning platform can increase your productivity by 10x. Most other companies out there will have tools that are perhaps disjointed from your overall ML pipeline. Some of them do this reasonably well, but by having a platform like Clarifai, you're able to integrate your ML pipeline directly into this. And not only are you able to use AI to automatically label within our Scribe labeler tool, but you're also able to use AI to auto-annotate inputs when you see them, as you receive them through the pipeline. Extremely powerful functionality. And with this, I want to thank you for taking the time to participate in today's session and bring it back to Trey to see if there's any questions at this point.
Couldn't have done it better myself there. Looks like we're out of time, so no Q&A on this session, unfortunately. Want to thank everyone who was able to join this call with us, and hope this was an informative look at the platform and a lot of different capabilities, and hope to see you there on the next session. Last note is that we will make this recording available for you to see after 24 hours, so be on the lookout for that. Thanks again, and see you soon.